In this video, we're going to take a look at how to configure Rapid Spanning Tree Protocol, or specifically Cisco's variant of that, which is Rapid PVST+, as we discussed in our last video. Let's see what our current spanning tree mode is right now. Let's do a show spanning-tree summary command, and it says that currently we're in MST mode. Remember, we set that up a couple of videos back? Well, let's change that on all of our switches. Let's go into global configuration mode, and we'll say spanning-tree mode, and context sensitive help shows that we've got an option of rapid PVST. And notice I say it's PVST plus, but it just says PVST there. The plus means that we're interconnecting our switches over a .1Q trunk, which is typically what we're doing. So I call it Rapid PVST Plus, but really that's just a specific type of Rapid PVST. Let's set this up on all of our switches. Notice I'm getting some error messages on screen because we have mismatched modes right now. Let's say spanning-tree mode Rapid PVST, and let's go to switch SW3. Same thing. Let's go to global configuration, spanning-tree mode Rapid PVST. Hopefully the error messages will settle down after we made those changes and everybody's running in Rapid PVST mode. In fact, let's do a quick confirmation of that. Let's do a show spanning-tree summary and just confirm that, yes indeed, the switch is in Rapid PVST mode. Excellent. Now, when it comes to influencing which switch is going to be the root for which VLANs, it works exactly like it did for PVST Plus that we learned about back in our CCNA studies. For example, let's go over to switch SW1. And let's say that on SW1, we want this to be the root bridge for VLANs 100 and 300. And we want it to be the secondary root bridge for VLAN 200. Here's how we could configure that, exactly like we did back in our CCNA studies. We're going to say spanning-tree VLAN, and I'll say 100, 300, root primary. I want to be the primary root for those two VLANs. Spanning-tree VLAN 200 root secondary is going to make me the secondary root for that VLAN. Now let's go over to switch SW3, and let's make it the root, the primary root for VLAN 200, and let's make it the secondary root for VLANs 100 and 300. So a very similar configuration. Let's go into global configuration mode, and I'll say spanning-tree VLAN 200 root primary, and spanning-tree VLAN 100, 300 root secondary. And then we'll do a show spanning-tree summary, and we'll see that we are the root for VLAN 200. Excellent. And if we go over to switch SW1 and I do a show spanning-tree summary, we'll see that I am the root for VLANs 100 and 300. Now let's zoom in on one of those VLANs to see the different link types that we have. We talked about link types in our prior video. Let's go into VLAN 300. We're the root for VLAN 300, so I'm assuming that we're going to be forwarding on all those ports belonging to VLAN 300, our two trunk ports. I'll say show spanning-tree VLAN 300. And yes, we are. We're forwarding on both of those ports, and they're designated ports. Remember that each link, whether it's passing data or not, has a port that's the designated port. And it's the port on that link that's closest to the root in terms of cost. We don't get closer to the root than being on the root. And we are, tells us very clearly right here, we are the root for this VLAN. We'll also notice that the type of link we have, in each case, is P2P. That's a point-to-point link type. And the reason it says P2P is because we're running in full duplex. If we had had these ports configured for half duplex, the switch would have assumed that we were connecting to a shared media hub, so the link type would be shared instead of point-to-point. However, if we had a port connecting to an end device, like a PC or an IP phone, it would still in most cases be running in full duplex, so it would also be a point-to-point link type. But how would we make that port an edge port on that point-to-point link? Let's take a look at some context-sensitive help. It's not super straightforward. We talked about it in our last video, but it's not super straightforward how to make that an edge port. If we go into global configuration mode, and let's go into a port that we're not using right now, I'll say interface fast Ethernet 1/0. interface fast Ethernet 1/0/1. I don't actually have anything connected there. But if I do a spanning -tree link type ? Notice that I can hard code link types of point-to-point and shared. I cannot hard code any sort of edge port mode. How do we do that? Well, it's not with this command, it's with our portfast configuration. If we go into this interface and say spanning -tree portfast, where we're saying, I don't want to wait for the normal blocking, listening, learning, or any of those delay states of spanning tree protocol. I just want to go active almost immediately because I'm connecting to an end device. I promise I'm not going to connect you to a switch. You'll never see a BPDU coming in on this port. Just go active almost immediately. That's what portfast does. And by enabling portfast, that's how we make a port an edge port. And let's finish the command out there, spanning -tree portfast. And that's a look at how we can configure rapid spanning tree protocol.